Good morning. This is your Stats Sensei, Mr. Spensei, and this is a test review, and we're going to run a hypothesis test and confidence interval based on regression, and our scenario is education and make educated and making it rain. So a study was done to determine whether or not there exists a relationship between education level in years and income level. So education level in years and income level. So we don't know which is our X and Y at this point, but we'll find out shortly. The data of median incomes and associated years. So income and years after kindergarten is provided in the table below, along with the computer printout of a regression analysis. Okay, so we have the printout. Now, we find the word constant. We know that that's our y-intercept row, and we know this is our slope row, which makes this our x. Well, since that's our x, we know years of experience is our x, and we'll go into L1, and y will go into L2. It says write the regression equation and define y and x in context of this problem. All right, so first off, I need to identify what my slope is and what my y-intercept is. Well, here's my slope, and this is my y-intercept. And we've already done that. So we've already done this part, and I'm going to go ahead and write that equation just because it doesn't hurt to have it. Y hat equals negative 52,654.33 plus 8094.67 and x. And when I said we did that in a previous video. So here it says run a test to determine whether or not the slope is significant at alpha equal 0.05. So we need to write the null and alternative hypothesis in symbols and in sentences. Well, as symbols, it's beta 1 equals 0 and beta 1 does not equal 0. And for this class, that will always be the case every single time. So this is my slope. Okay. So my slope is 0. It's in other words, we don't have any, that says that there is no linear relationship. That says that there is a linear relationship. Well, we're looking for a linear relationship between what? Between annual income and years of experience. Remember, we're always going to go Y then X. So there is no linear relationship between annual income. Well, this is my Y and years of in school. And you could have said education level, and that would have been fine too, but this is my Y and this is my X. And then, of course, changing it up to be the opposite, instead of there is no, there is a linear relationship between annual income. Once again, this is my Y, and number of years of school is my X. So Y and X. So the formula is T equals B over SB. But what the question is, what is B and what is SB? Well, I'm glad you asked. B is my slope, and SB is my standard error of the slope. So remember, that's my T statistic. So I can go back to the table and go, you know what? This is my slope. That's my SB. So I should be able to take 8,094 and divide it by 731 and get 11. So let's see if that actually pans out that way. Let's see if that works out that way. So 8,094.67 divided by 731.67, and we get 11.06. So sure enough, we get our T statistic right there. So, but before we do that, that tells us that formula actually works. Let's calculate our degrees of freedom. Our degrees of freedom, if I sit there and go count this up, I have 1, 2, 3, 4, 5, 6, 7, 8 levels. So degrees of freedom is n minus 2, which is 8 minus 2, which is 6. But we already have that, and we can pull it straight off. So our degrees of freedom in this case is 6. All right. So with that said, let's go ahead and plug into our formula and see what things look like. So when I plug into my formula, I end up with the slope, the 8,094.67, which is my slope, or this is my B over my SB. So 8,094.67 divided by the 731. And that gives me that T statistic of 11.06. Well, we have a p-value of 0. And when we were reading this, they said that they wanted a alpha of 0.01. Well, 0 is definitely less than 0.01, so we reject the null. Once again, the first two sentences of our conclusion come from this regression box. So our p-value is 0, which is less than our alpha 0.01. We reject the null. Like I said, that came straight from our decision box. So there is sufficient evidence to suggest, and remember, it is because we reject it. If we fail, it's a not. So there is sufficient evidence to suggest the true population slope results in a linear relationship between annual income being my Y, and number of years in school or education level, either one, which is my X. Always sticking with the YX order. Okay? All right, that takes care of the hypothesis test. Now we need to do the confidence interval. Well, they want a 95% confidence interval, and our formula is B plus or minus T star times SB. So B plus or minus T star SB, where this is my slope, and this is the standard error of my slope. And please remember, this is T star. This is not a T statistic. This is a T statistic. So this is a T stat. This is T star. T star comes from the calculator, and we're going to have to go through a process to calculate that. To calculate it, second here, we're going to have to go to second vars. Second vars, inverse T. And what did they want? They wanted a 95% right here. So we're going to go clear that out, parenthesis 1 minus 0.95, close parenthesis, divided by 2. And then they asked for my degrees of freedom. Well, my degrees of freedom was given to me here. We also wrote it up above, way up here. So my degrees of freedom is 6. And we get a 2.4469. Now it's negative, and we're positive people, so we turn negatives into positive all the time. So 95%, that's the confidence level. 1 minus 0.95. Once again, that is our C level. That's our CL. 6 is our degrees of freedom. And that's what we plugged into the calculator. And when we did that, we said, oh, we got 2.4669. So now I'm going to just plug into that formula. And when I plug into the formula, I end up having B, this is my B or my slope. This is my T star that we calculated right here. And this is my SB or standard error of the slope. And remember, slope came from here, and there's SB. All right. So those are the two values that we plugged in. Now to get my confidence interval, I'm going to have to approach this with plugging it actually directly into the calculator. And I always start off with the minus first. So 8,094.67 minus 2.4469 parentheses 731.76. So I end up getting a lower bound of 6,304, which I recorded right here. And I like to say that that's a lower bound. And just to remind, we subtracted to do that. We do that first. And then I'm going to do the upper bound. And I'm just going to go up and select that and change that to a plus and press enter. and I end up with 9,885. And this is my upper bound, and it's positive. So basically, what they're saying is, hey, we expect that you're going to make 6,304 to 9,885 dollars more for every year more of schooling that you get. Okay. All right. Last, we're heading to our uh, section of writing our conclusions. So, what are we? Well, we're 95% confident the true population slope for annual income relative to years of experience lies within our interval that we just calculated. Now, I want to point this out to you again. I know this by now, you're probably tired of hearing it. Annual income is my Y, number of years of experience or education level is my X. All right. Then finally, in repeated sampling, we expect this method to capture the true population slope for annual income relative to number of years experience 95% of the time. Or once again, this is my Y and this is my X. All right. Appreciate you watching and look forward to seeing you on the next one. Thank you.